How to Lighthouse. And welcome back to Simple Circuits 101. This is my latest project. Its design and construction are fairly straightforward, and if all goes well, it should take you just under an hour to build. Its power consumption is minuscule and should work continuously for several months. These are the components used in the project, and it also comes with a 3D printed base. I'm using the blue tack and spit roast method as before. Also, Mr. Cylon is overseeing this project. Ignore him at your peril. Start with the discrete components first. Pop those in and align them as you go. Secure with a bit of blue tack here and there. Turn it over and just straighten out the component leads. Apply solder like so. I'm using standard leaded 6040 rosin cord solder. I find it easier to work with and more reliable than the alternative lead-free version. Pay particular attention to the idents on the transistors. Q1 at the top there and Q2 at the bottom. I'll talk more about those transistors later on in the video. Solder the middle legs first. This will allow you to true and straighten the components. When you're done, turn it over and secure the other legs. This is capacitor 2 at 330 nanofarads. Oops, dropped it. Try again. And secure. The long leg of capacitor 1 is positive. Align this with the plus mark indicated on the PCB and secure. As with capacitor C1, the longer leg of LED 1 indicates the positive terminal. Carefully form, fit and secure. For this type of project, I use an unconventional soldering technique. This is the conventional solder joint, and this is what I like to call the solder dome. It gives a particularly clean look to the project. To achieve the look, you first make a conventional soldered joint, crop the component leads off very close to the PCB, then resolder the joint once more. It's the close cropping and a second pass which give the joint its distinctive dome-like effect. Apply sticky pads to the underside of the battery carrier and then carefully position between the two transistors. Note that the negative, the spring end, is to the left of the picture. Once satisfied with the positioning, press down firmly to secure. Address any solder joints that may require attention. Give the project one final look over, and then if you're happy, pop the battery in, and after a few seconds the LED should begin to flash. Give the project a quick scrub down using methylated spirits or denatured alcohol, and you're good to go. Nice! This is the circuit diagram for the Lighthouse project. It's a very simple circuit and has just 9 components. At the heart of the circuit is Q1, which is an NPN transistor, and Q2, which is a PNP transistor. Both of these components I would describe as being vanilla, meaning there's nothing particularly special about them, and other components of a similar profile can easily be used as substitutes. I've experimented by changing the various values of the components to get what I believe now is a circuit optimized for longevity and reliability. Let's take a closer look at what's going on here. This type of circuit is called a regenerative oscillator. I'll give you a quick rough and ready explanation of how it works. The cycle begins with capacitor C1 charging through resistor R4 up to the supply voltage of 1.5 volts. Now, this isn't enough to illuminate LED 1 because this is a warm white LED and its forward voltage is about 2.5 volts. Whilst capacitor C1 is charging, capacitor C2 is also charging, but at a much slower rate through resistor R1. When the charge reaches above 0.6 of a volt, Q1 begins to conduct. This in turn causes Q2 to conduct. Q2 feeds back in to Q1 and causes Q1 to conduct even harder. This in turn causes Q2 to conduct even harder until we reach a point called an avalanche effect. When this happens, all of the supply voltage will instantly be delivered here. This will combine with the charge stored in capacitor C1 and present about 3 volts to LED 1. LED 1 will illuminate briefly but intensely until the charge in capacitor C1 is exhausted, at which point the whole process will begin again. This has been a simple but fascinating project. I've experimented with changing various values of the components. I went for a higher value initially for R2 and R3, but I encountered a startup issue. So I've reduced the value and now it starts reliably every single time, perhaps at the expense of longevity of the battery, but since we're talking in terms of several months of operation, I think that's a valid sacrifice. Also, I've changed the value of C2. Initially I tried 220 nanofarads and that gave a flash rate of 1.5 seconds. It's currently 330 nanofarads and that will give about a 2.8 second flash rate. As for C1, I found it's not as bright if you go lower than say 47 microfarads, and also I did try it at 220 microfarads and you get this strange sort of flash and then slow fade, which wasn't what I was going for really. The values here are optimized for brightness, periodic space and longevity of the battery. Nice. I hope you enjoyed this project. If you did, please like and subscribe, and I'll be posting another project soon.